All right. Example 2. A rectangular lot is bounded on one side by a river and the other 3 sides by a total of 80 meters of fence. Determine the dimensions of the largest area. The largest area, we're finding the maximum again. So we're finding max and min. That's what the title is called. And just to, briefly draw it, there's a river. That's what rivers look like. And then we've got some fence. And it says it's a rectangular fence, and we are trying to find the area. Now, area is going to be length times width. And what we need to remember when we do this is we don't need a fence along here. So we're going to have length times width. There will be a width on this side, but we don't need anything up here. The river is enough to contain whatever we're putting in. So what we are looking to do, we're trying to find, like here, see I put a star minimum. We're trying to find the minimum product. Here, we're trying to find a maximum, which I can't spell, maximum area. So that's what we're trying to find, maximum area. And area, as you know, is length times width for a rectangle. Just like here we had product was 2 numbers, A times B. Here the area is length times width. Now, like I said last time, there are too many letters. I can't solve anything with all of these letters. So hopefully there's a formula or something they can give us that will help us to get rid of one of these letters. So in this question, they said, well, hey, the 2 numbers have a difference of 10. So I wrote that down. The 2 numbers, if you subtracted them, got you 10. Here, it said that we've got 80 meters, I think, meters of fencing. I don't remember if it was meters. I zoomed in, zoomed out. Yeah, 80 meters of fencing. Meaning that if we added up this width plus this length plus this width plus length plus width, if we added that up, the width plus the length plus the width, we would get 80. Now, this is a W and a W, so you can write that as 2 W's. So the length plus 2 W's gets you 80. And the idea here is, can we get one of these letters alone? So if I move the L over, don't do this, but if I move the L over by subtracting it, I have a negative L plus the 80. Then I have to divide by 2. So there's 2 steps there. Move over the L, then divide by 2. What I'm going to do instead is just move over the 2W. And then one step, you can get the L alone. So there's a negative 2W plus the 80. Now that we have that, that's what the length is. Length is going to be negative 2W plus 80. We can plug that into our maximum formula. So area equals length. Length is negative 2W plus 80. So that's what that is. And then we've got the times W. So I literally just replaced the length. So this is the formula for area. We had too many letters, so we used a different formula, isolated the L, and plugged the L in. I can multiply this W in now, so I get a negative 2W squared, and then plus 80W plus 0. I'm including the 0 in there because I want to find the vertex. So to find the vertex, take the middle number, 80, cut it in half. I'm going to get 40. Then take that 40 and divide it by the number in front, divided by negative 2, get to negative 20. So I'm going to create a square. Now normally I put an X here, but I don't have X's, I have W's. And so then here I can put the minus 20. So there I've created my square. Now you're going to FOIL that. Now, oh, and I have to carry this negative 2 down. Now you're going to FOIL that and times it by negative 2, but the faster way was to go, well, I'm just going to do this part. So negative 20 squared gets me 400. And I'm going to take that number and times it by negative 2. So I'm going to take negative 20 squared, which is 400, and times that by negative 2, which is going to be negative 800. So I'm at negative 800. What will it take for me to get to 0? I'd have to add 800. Negative 800 plus 800 would get me 0. So I'm going to erase this blue and green stuff here if we need to pause this. This is just work that I did for completing the square. Now that I've completed the square, normally you'd have x comma y, but I don't have x comma y in this. I'm going to move this over a little bit. X comma y. My y, usually is y equals, my y is a. And normally my equation has x's in it, but here I have w's. So keep that in mind, okay? My vertex is going to be the opposite sign, so positive 20 and 800. So this is, if you look here, A, so this is my area, and this is my width. So my width, my W, is 20, and my maximum area is 800. So if you had your rectangle, and this is 20, and this is 20, and you know you only had 80 meters of fencing. Well, 20 plus 20 is 40, and then what would you need to add here to get to 80? Well, add 40. So now if you go 20 plus 40 is 60, plus another 20 is 80. That works out quite nice. And so this is my length. So it didn't tell me that. I had to do a little bit of calculation, but my length is 40. And it's all in meters, and area is squared, so meters squared. All right, so that's that. Just to quickly recap, your finding, it says largest area. So I wrote maximum area. Area of a rectangle is length times width. Too many letters. So I used the other formula that they gave us to isolate one of the letters, and I threw it in. I multiplied it, got a quadratic equation. Normally it has x's, but here I have w's. I completed the square, found the vertex, and then I had to interpret the vertex using not x and y, but instead w and a. So my width was 20, and my area was 800. And then I could do some basic calculations on the perimeter and find out that my length is 40. So we'll do another video for the next question.